and tell me what shape you see. There's kind of a distinct shape, something you can almost say to tell people this is an absolute value graph.
Tell you what it looks like.
Yeah. Yep.
It's like a little, hold on, let me get it, but I'm pretty sure I know what that, I'm pretty sure it's like a little U or a V.
It's one of them. Yes,
This comes out to a V.
it is. And that's
Absolute
really
value is
important.
always V.
Yeah, it's always a V. Could be an upside down V, could be moved around. And that's what's going on here is there are actually, when we go back and grab, well, I grab this again. There are two transformations. And I know sometimes you get problems where you actually have to list the transformations. Can you tell me either of the transformations in this? You got a -3 and a +1. I'll take either of them.
Okay, well, the minus goes negative, but really it's an absolute value. That doesn't matter though.
It doesn't matter that it's inside the absolute value. There's something when it's inside parentheses, it also applies to quadratics.
Okay, so then -3, so it's going down. So
The up and down is on the outside. This is the up/down part. Inside is the right/left.
oh, going to the right 3.
Right 3, yes.
And then 1.
Up 1. Okay. So the right 3, does that affect the X or the Y?
The X.
It affects the X. Now, how about the up 1?
It affects Y.
Affects the Y, yeah. And transformations only affect one or the other. Like every transformation only affects one. Cumulatively, they all affect the graph, but you have to be able to do it in stages here. And that's what they're trying to show you here. So to do that, we're going to look at this transformation. And I'm going to grab the table of values that we did for the parent function. So you are responsible for knowing the parent function. That's for sure. And then we're first doing right 3. So that means every X value is moved to the right 3. Could you tell me those new X values, please?
Five, 4, 3, 4, 5.
Okay, so just be careful with that you're adding 3. So that's why these last 3 are fine. You're adding 3 to the X values only. You said it affects the X.
Okay, so
yes.
2 and then 1.
Yes.
Got it.
Okay. The Y values have no change.
Right.
Okay, so go ahead and graph that for me, please.
Got it.
All right, so you should have something that's over here and just kind of, it looked the same. It's just literally moved to the right 3 like we just talked about, something like that. Okay. They want you to show it in stages, but you may be the kind of student that can do it all at once, but just always be careful, slow and steady. If you can. So the last transformation is up 1. And you said that affects the Y values.
Correct. Yeah.
So you take your, well, I should go and grab them. You take your previous set of Y values. I actually think they should make you do a table each time. We're doing it because it is helpful. The Y values go up 1, every single one.
Mm-hmm.
So give me the new Y values, please.
3, 2, 1, 1, 2, 3.
3, 2, 1, 2, 3.
Yeah.
Very good. Go ahead and graph that for us, please.
Got it.
So again, should just look like the previous one, but then,
Just up one.
yeah. Now, good question over here on the right where it asks you for the domain and the range. Domain and the range.
Domain is all real numbers.
That's true. The range though is your min to your max. So you got to think about like, well, what's the bottom point here? And it's 3,1.
Yeah, 3,1. So
What's the smallest y value to the largest y value?
I mean, technically the y is just going to be repeating, right? Or
Well, what y goes up from like, what's the smallest y value? And it's at the vertex here, which is the y value.
one.
One. So the y values, are they getting bigger than one, less than one?
Greater
What do
than.
you see?
They're getting bigger.
Yes, and it also includes one.
Yeah. Okay. Got it.
And you need all that other stuff as well. Okay, do you want to try graphing one of these on your own? Maybe like this?
Yeah, sure.
Okay. So we'll do the same thing here. There's 3 graphs. I'm really only interested in the last one just because I think, this is the first time you're seeing this, so you are, aware, but listen, we're not gonna make it too complicated. So let's say it's y equals absolute value x plus 1 minus 2. Okay. So you don't have to graph the parent
Okay,
function.
and just to be clear, I just plug in for x here, right?
Well, I want you to graph it the way we just did. I mean, I would like to see, the parent function. I want you to graph the 2 transformations like we did, where you make a table and go through it. What is the first transformation? That maybe the
To the
important
right
thing.
one.
This one is actually left one.
Oh, left
Why is it?
one, that's
Yeah,
positive.
why is it? Yes.
Yeah,
Now what about the
positive one? The next one's down 2.
down 2? Yeah. All right. So yeah, you could make a quick sketch or make tables, whatever you feel like is the.
And then tell you my points, or I mean, I have my graph.
Yeah. So I'll just graph them for you. So the first one, left one, should be a vertex right there.
Yep.
Something like that. And then the down 2 just moves it literally down 2. Every point moves down 2. So it's going to look something like that and like that, roughly.
Yep.
What I'm more interested in is the range. You giving me the correct range.
Oh, okay. All
Correct
right.
range on this.
Y is greater than or equal to -2.
Yes. Very good. Very good. All right. So let's look at problem number 3 together here. 3A. It's you see questions kind of like this on the SAT, but they're not written this way, but they're of this style. Let's just try solving it the way we normally do, which is you set x minus 2 equal to -1. That's like case 1. And then x minus 2 equal to +1.
And then
Remember,
solve
that's
it.
kind of the general thing you do.
Yeah.
You do case 1, case 2, add 2, add 2, add 2, add 2. So you get x equals 1, x equals 3. Does that make sense?
Yeah.
Okay. Now, you've heard this for years, right? Check your answer. Check your answer. I'd like you to check your answer, check one or both, and tell me if you see any problems. Like
With
when you
them
put
being part of the equation.
one back in here or three back in here, tell me what's wrong, or tell me why it's a problem. They're both a problem, but why? You know, what is it that's the issue?
The first one equals 0. Or no, the first one is 1 equals -1.
That's right. And that's bad because that's
Yeah.
not true.
Let me get the second. And same with the other one.
Yes, it's the same thing. Now, but we solved it, right? Didn't we solve it? We did the
Yeah.
thing, and we're like so. A couple things is like, first is like you should always check your answer. Just always do it. The but really that's not what they're asking for here. But if you just blindly do something, you always should check your work. They want you to explain why it does not have a solution. And the reason is the absolute value function, absolute value returns positive or 0. Okay, and by that it means it never returns negatives. Never. Okay. All right. So we shouldn't be surprised. I could give you the absolute value of something that's 2x minus 5, something awful, equals -4, and you say no solution because absolute value never returns
Got it.
negative. Okay. Now part B here, part B, this is something your teacher does a lot of. They want you to graph each of these individually. So they want you to graph, like they want you to treat this as a y, y1 equals absolute value x minus 2. And they want you to treat this as a y, y2 equals -1. They want you to make a sketch. Okay. And so you have to remember your transformations. What does -2 do for a transformation?
To the right too.
To the right too, yeah. Okay. So let's move absolute value to the right too. Look, something like this and like this.
Yeah.
Oh, and by the way, what's the range of this absolute value? Might as well throw that in.
Y is greater than or equal to 0.
Yes, very good. Okay, now the next one, the line here, y2 equals -1. What kind of line is that, or what's the name you could give to that line?
A dot or negative. I mean, it's coming down.
It's got a special name. It's
Oh.
like when you're playing basketball, there's certain types of shots, and you don't just say, oh, he's shooting. You can be more specific about what that is. And I think I mentioned before, I used to read it this way: y is always -1. I don't know
Y
if that,
is negative. Yeah.
yeah, I don't know if that helps, but that could lead you to what to graph here. I'm trying not to just give you the answer, but you maybe look back or. All right, I'll give you one more hint here.
Yeah. Give
So
me
I
one
pick,
more hint. I'm
so I
so
pick an x value. I'm like, what if x is 2? Well, y is always -1. What if x is -4? Well, y is always -1. You need 2 points for a line. 2 points for a line, and then you connect them. So could you graph these 2 points and connect them?
Yeah. So it'd be But I can't just make a number up, right?
Well, no, you pick an X though. You pick an X, but Y is always -1. I'm
Okay, so
asking you
then,
just,
3 comma -1, and then,
sure. I mean, you can use these points. Like, I just want to know what you graph when you're done, or tell me what the line looks like.
and then -2, -1, or,
Sure.
yeah,
Sure. Yes.
got it.
What does there should be something noticeable about that line.
It's off, or not all the points are on it.
Okay, maybe which points? So I'm going to graph these 2 points, 2 -1 and -4 -1. And then I'm going to connect them. And I'm guessing maybe you didn't graph this right, but I was looking for the word horizontal line.
Oh, like on the same page.
Yes.
Yeah.
Oh, okay. Yeah, you have to graph it on in the same graph space. Okay, now do these intersect? Does the red intersect the V?
No,
So that's graphically show why it does not have any solutions. It's
because
because
it
they
never
don't
hits
understand. Yeah, exactly.
it. Got it.
All right, so let's look at number C here. All right. Ignore the words for a moment. Let's just go about looking at how to solve something like this. So that whole case 1, case 2 stuff, it only applies once you have the absolute value equals a number. Like you can't have a negative on the outside. You can have a fraction. It can't be like +3 or -5. So
Right.
in this problem, we know we can do this when we're down to X + 2 absolute value like that. Okay, so let's
Okay, I
first
got it.
add one. All right, so
Okay.
that leaves you with -1/2 absolute value X + 2 equals 5. You can undo -1/2 a couple of ways. What most students tell me, and this isn't wrong, but they say divide by -1/2. It's just hard to divide by a fraction. Like it's just awkward. Okay. It's like trying to do anything with your opposite hand. Like it just doesn't usually go well.
Yeah.
Unless you've done a lot of practice. Now you could multiply by the reciprocal, which is -2, and that is better. That is the better
Right. That's what I'm
path
thinking.
here. Okay. X + 2 equals -10. All right. Now,
Got
do
it.
you see any issues with what is written here in terms of solving it? Like we're about to solve, but do you see any problems?
No. Well,
Why doesn't this have a solution? What's the issue with this?
because of the vertical line,
It's a horizontal line, but
of the
it's
horizontal
more,
line.
it has to do with this number over here on the right.
Oh, the -1, the Y.
Yes. Absolute value always returns positive or 0. Is there any way for the absolute value of X + 2 to be a negative number?
For the absolute value or the,
Yes, the absolute value.
no, absolute value can't be negative.
That's right. So this has no solution.
Oh, I see.
Now, I don't know why it's
Can't solve
asking
it.
you this question. Maybe it meant to say explain why you don't.
Oh,
I really don't know. But this is a garbage question. But there is no solution. I mean, you can do exactly what we did earlier, which is set up 2 equations, solve them, and get an answer, and they will both not work.
I see. All right, I've got those down.
Now we should actually solve one that does work. So let me give you one that actually does work here. Let's go 1/3 absolute value X -2 -7 equals -5. Yeah, that's a good one here. So this one does work. It does have two solutions. I'd like you to try solving this, please.
Wait, I have a question.
Yes.
So I have absolute value x minus 2, absolute value equals 6.
Okay, that's correct.
And now I want to put it down to x plus 2 equals 6.
Nope, nope, no, it's the same thing. On the left, always the same on the left, equaling plus and minus. So on the right, it'd be -6.
Okay, got it. X equals 8, x equals 4.
Only one of your answers is correct.
X equals -4 for the one.
Yes, yeah, there it is.
Got it.
X equals 8, good. Okay. All right, well, let's reset here. We'll move to the next page there, problem 5, I guess. I don't know, that's the next picture that came in, maybe. Yeah, that's fine, that's the order. This is kind of a condensed version of what we were just doing, but good to do here. So they give you a function. I'm going to tell you it has 3 transformations. I'll take any of them. Can you tell me any of the transformation? You got the 4, you got the -1, you got the -8.
Yeah, your first one, you're going to the left 1.
Left 1, I agree. Keep going. Doing great.
Now you got to go down 8.
Down 8's the last one.
And then the 4.
So that's a vertical stretch.
Vertical, yeah.
Stretch by 4. Okay. All right. Now, before we graph this here, can you tell me whether this affects each one of these, whether it affects the X or the Y? Does going left affect the X or the Y?
The X.
How about the vertical? Well, actually, let's do that now. What happens to the X? What does this -1 mean? Left 1. So what do you do to that X value? Do you add 1 or subtract 1?
You're subtracting 1, I guess, because
Yes,
you're going to the
yes.
negative side.
Yep. So you can write subtract 1. If you like more like this notation, you can do X, it becomes X -1. It's all good. Vertical stretch by 4, does that affect the X or the Y?
Y.
Okay.
And then down 8.
On the Y here, do you remember what a stretch does in terms of does it, we haven't covered it today, but that number in front, do you remember what it does to the Y?
Is that like that line? It's like the cutoff point. I don't know. It's like,
Okay. Yeah, so you end up multiply by 4.
oh,
So Y becomes 4Y. And then down 8, you said affects the Y. Could you tell me what that does? Do you add, subtract, multiply, or divide by 8?
subtract.
Yes, subtract 8. So the Y becomes Y -8. Okay, so we're gonna make a table. And this is enough to do, like, we can do the entire table in one step here. So the parent function, we don't have to, but the parent function is -2, -1, 0, 1, and 2. 2, 1, 0, 1, 2. Right. So we can either do this all in one step or do them in 3 steps. What would you prefer? What makes the most sense to you? To do 3 separate
Let's
tables
do it
or
all
try
in
to do
3,
do it all in one time, or 3 tables? Sorry,
all in one time.
all one time. Okay.
Yeah.
So the X, you're going to subtract 1 from each X. So give me the new X values, please.
I'm going to subtract 1.
Yes, from every X value. That's left 1, subtract 1.
-3, -2, 1, 0, 1.
Good. The Y is a little bit more complicated, and you probably noticed that even though you said down 8 first, I put it down here at the bottom. The order matters.
Yeah.
And it matters in a lot of things we do in life. The order really does matter. So we don't have to talk about why, but it does matter. So first thing you're going to do with the Y's is multiply them by 4. Then you subtract them by 8. Okay, so you take this 2, you multiply it by 4, and then subtract 8.
Okay.
So can you do that for me? Times 4, subtract 8.
Zero, -4, -8, -4, 0.
All right, and did you notice the symmetry here?
Yeah.
Just like you have here. So you don't
Added.
have to actually recalculate them all. You can just do enough till you can get the symmetry. Totally up to you. And then if you wanted to, you can make a quick sketch of this. I mean, you got -3, 0. You got to go way down here. We'll just roughly say that that's it, right? Something that looks like that, not to scale.
Got it.
All right, good job. Now we've actually already done part B, but we should look at it sort of just in context of, okay, what would you do if you just got part B and on a test here? So the function f of x is given as the absolute value of x minus 3. F of 0 means to put 0 in for x. This is the absolute value of -3, which is 3. So graphically, it's this point here, which, oh, I'm doing the wrong problem. I grabbed a snip from the other page. It's
You're
like,
good.
hey, that's not right. 4x. So try this again. 4 absolute value 0 minus 1 minus 8. You correctly found that that's -4. So the graph of that goes down, down here-ish, 0, -4. But more importantly is like, well, what does it mean? What does it mean when x is 0? When x is 0, this is the y-intercept.
The y-intercept.
Yes. When x is 0,
So
it's the
-4.
y-intercept. Yes. And then we also talked about the other day, when y is 0, that's the x-intercept.
Got it. And you said this was sort of for part B?
Yes, this is for part B.
Okay, got it. Got it. All right.
And that's the key feature. Did you find?
Key feature?
Yeah, that's the y-intercept. The y-intercept is the key feature.
Oh, right, yeah.
And of course, the next part, C, is the other one, which is the x-intercept. Okay. That's setting the original function equal to 0. So we've actually already done this in the table. That's why it's saying, use the table, but you're replacing f of x with 0. 0 is equal to 4 at the value x minus 1 minus 8. And if you're like me, you don't like that 0 on the left, so you move it to the right.
Yeah.
Now we already have it from the table, but what I'd like you to do is you've done this a few times today, is to solve this, setting up that case 1, case 2 after you get the absolute value of x minus 1 isolated. And we did this on the other page there.
All right, so solve this.
Yes, please.
Okay, solved.
Okay, what are the two values you got? X equals what and what?
-1 and 3.
Yes. And if we go back to the table,
Right there.
it could be +1 and 3, +1 and -3. So there's some sort of a signer there. Let's take a look here. Those look familiar, but should have been absolute value x minus 1 equals 2. Is that what you have?
Yeah.
2, right? Why isn't this working out?
I have no idea.
Yeah, I'm a little okay. So it's equals 2 equals -2. X minus 1 equals 2, x minus 1 equals -2. When you add 1, add 1, add 1, add 1, you do get the 3. That's the one I was expecting, but you also get you get -1. I heard something different. Maybe just my bad hearing here.
No, I said -1.
Okay, then we got them right.
Got it.
Fantastic. All right, good job. So those are the x-intercepts. The x-intercepts are at 3, 0 and -1, 0. Those are the x-intercepts. So like the main thing that you're trying to figure out here when you're looking at these problems is they're going to give you some sort of f of x. It's going to equal 2 absolute value x minus 3 minus 4. Okay. And there's two things you can find. The first is the y-intercept. That's when x is 0. You're literally finding f of 0.
Yeah.
Or the x-intercept is when y is 0. It's 0 equals the function. So in one case, you're putting 0 in for x, and then the other, you're setting the whole thing equal to 0.
Got it.
Is that clear?
Yeah.
All right. Okay. Why did they change it up on us? So your instructor, that's got to be a typo. So you'll notice in D, it's the different function. It's +8 instead of -8.
A D.
Yes.
Yeah.
And I don't know what to make of that other than to say, doesn't seem right, but because the difference is one has a solution and one does not.
Oh,
And,
they
and I
want
guess,
to guess which one has it.
well, if it's -8, it has a solution. So I think I'm going to just go off the assumption that they meant for this to be -8, and you can check
Okay,
with your instructor later.
so solve for it like that.
Well, we're gonna do this together. So you end up getting absolute, yeah, greater than or equal to. So we have not done one like this in a while, although we have done problems like this.
Okay.
So it's totally doable. Just maybe not, not a favorite. So when it's a greater than or equal to, it's kind of also a case 1, case 2. It's x -1 greater than or equal to 2, and then x -1. But this time it's flipping the inequality
Oh,
and negating.
okay. Flip it and negate it.
And then from here, you are solving for x. So you're adding 1 to both sides, adding 1 to both sides.
X,
So you end up getting x greater than or equal to 3,
X,
x less than or equal to -1.
got it.
Okay. And it's easier to do this on a number line to graph the solution. So you put those two x values on there. I'll call that -1 and I'll call that 3. So the one on the x greater than or equal to -3 on the left here, you go to 3 and you graph everything to the right.
Mhm. Got it.
-1, you graph everything to the left.
Got it.
Now, interval notation, we really haven't done much with set notations. Let's just do interval notation. Okay. You say you do the whole preamble x such that x is an element of the real numbers. Okay. But then you write x is less than or equal to -1 or
Oh,
x is greater than or equal to 3. So that or word is really important. That means they're both okay.
got it. Or.
All right, so let me give you one to try. That's okay.
Yeah.
So let's go 1/2 absolute value x +1 -5 greater than or equal to 0.
Do you want me to solve it out with my case 1 and case 2?
Yeah, give me just the inequalities when you're done, like x greater than or equal to, x less than or equal to, or whatever you end up getting.
X is greater than or equal to 9. X is greater than or equal to -11.
This is what I heard, but one of them's got to be flipped, like probably the one on the right.
Flipped to what? Like,
Well, if when you got back, if the previous problem, notice we wrote same thing on the left, x -1 greater than or equal to, but then this one flipped. It was less than or equal to.
yeah.
So the way you said it, and then maybe you didn't mean that, was these are both the same direction, but it can't be. Okay, let me, so you probably got it down to this. Is that right?
Yeah, I do. I did.
Okay, very good. So you split this apart, x plus 1 greater than or equal to 10, x plus 1 less than or equal to minus 10.
Yeah.
See how the inequality flipped?
Yeah.
Okay. Subtract 1, subtract 1. So x is greater than or equal to 9. Subtract 1, x is less than or equal to negative 11.
That's where I went wrong. Yeah.
Okay, so very important. And usually it's one to the right, one to the left when you're all done. So it's not like usually that's the case. You don't get too many exceptions to that. And then graphically, what would that look like graphically? Well, these are further apart, but you're typically shading one to the right, one to the left. Okay.
Got it.
Why are these filled in here? Why are these filled in circles?
Oh, because of the line under the greater than or equal to.
Yes.
Yeah.
Yes. So if I give you one that's not filled in, you would not include it. Okay. So let's do that now. Let's say it's absolute value of, I don't know. Let's go 2x minus 1 greater than 3 this time. All right. So why don't you try solving this for us? Kind of same thing. Case 1, case 2.
X is greater than 2. X is less than or equal to -1.
So when it's a less than or greater than, if like in this case, it's greater than, when it flips, it goes to a less than. There's no sign underneath like that. That sounds correct here. Let me just double check you here. 2x minus 1 less than -3, 2x greater than 4. So x is greater than 2. You got the first one right. 2x less than -2. X is less than -1. Yeah, both correct here. All right. So on a number line, what would that look like? This time it's
Open.
an open circle at -1, open circle at 2, again, not to scale, left, and then right. And when you give the answer, you have to say x less than -1 or x greater than 2. You include both of them that you solved, like exactly the way you solved, but typically the one that's left comes first, then the one that's on the right comes second.
Got it.
Okay. All right, so we did not get through, everything.
All
Let me
good.
just take a quick look. I don't know if there's, let me see what else, just we need to make some quick comments, but you got to know your transformations. Looked like
Yeah.
there was another transformation problem on there. That whole thing about f of x equals 0, x equals 0, that stuff right here, that's really important to be able to distinguish quickly between. But if you understood that, you should be okay. I'm gonna go ahead and stop the recording right here.